Not all enterprises can start moving data into the cloud or into Microsoft Azure, but there might be some data that can be, quote, archived to a repository. This data is not assessed frequently, but the business rules or some sort of regulations for the company require that it be available within a certain time range. So archiving seems to be the path that people go by. And usually they create something like a link server in a view that might join tables from various databases on various servers. Azure provides this in SQL Server 2016 with a feature called Stretched Database, or StretchDB. This is just an option. On-premise is usually the preferred area for this data. This can be in an Azure database or an Azure virtual machine with SQL Server 2016 installed. Some people used to use a link server for a very similar thing, but this additional option is now transparent to the user. It is good for data that never gets updated or deleted. RDA, as it's called, or Remote Data Archive, is a feature that provides the unused data in the cloud in an Azure database. But you don't even have to know as a user where the data is located. It's kind of a hybrid feature. You're always querying the table on the SQL Server 2016 on-premise instance, but behind the scenes, the archive data in the cloud is retrieved if needed. The query uses the same table, so there's no changes in application or reports, which should make most people very excited. This predicate always is a where condition. The where condition is the known area to place the current data that's being used on premise, whereas the stuff that's not used frequently gets put in Azure. The data is stored remotely and in the cloud, but it appears to be local. When using Stretch Database, you're always going to want to know if and what I can use in a database or a table to place in the cloud as archive data. There is an advisory utility that can be used to get the assessment of a database or databases and its tables, even the objects like stored procedures. You'll be able to see, first of all, if the table is actually a good candidate. Usually it's something with a high number of rows, or percentage-wise in the database, what seems to be the largest tables. But some check constraints prevent the data from moving to a stretched database. So the inspection of this assessment tool can look at an upgrade as the features that can be used with SQL Server 2016. So you get two results: possible candidate tables and the limitations of constraints that are on tables that prevent it from being moved to an Azure database. This advisor can be downloaded from Microsoft and is part of the installation program for SQL Server 2016. Enabling Stretch Database can be performed in two different ways, T-SQL or Wizard. So enabling Stretch Database on a table can be used through SQL Server Management Studio and its GUI. Or you can use some T-SQL scripts, which are not complicated, to accomplish the same things as SQL Server Management Studio. The wizard is nice because how fluid it steps you through requirements and connections. And most people are usually familiar with wizards and their flow. But hardcore DBAs are always going to want to automate this function in some fashion, or even place it in PowerShell. No matter what option, it is very easy, and most DBAs are going to be excited about this feature. Archived data in Azure through StretchDB cannot be updated or deleted, so it is truly archived data. You will need an Azure subscription in order to develop and release to production. So you can get started with a credit It's usually about $200 as of May 2017 through something called Visual Studio Development Essentials. Also, if you have certain MSDN subscriptions like Universal, you can have a certain amount per month waived from your Azure subscription. So once you have this database tested through the advisor, you can stop the database to not continuously get charged in Azure. We're of course talking about the development, not production. So you can start and stop these services in Azure so your credit will not diminish. We're going to look at a demonstration of the advisor along with our connection into Azure. As you can see, there's a dashboard in your portal.azure.com site that shows all the resources and the health of the systems around the country. We can create a new one by clicking New, going to Compute, and picking SQL Server 2016 SB1 Enterprise on Windows Server 2016. It'll give some description of the image that's going to be used for a resource manager, and you click Create. Here you have some basic settings, some sizes, settings for the feature, and then also the SQL Server configuration. We'll do a test for LearnNowOnline, and we'll tell it what kind of disk to use, and we'll give it a name and a password. You need to remember this because this is going to be your administration password. It's very particular about how strong this is. It's free, and we're just going to give it a resource name and click OK. Here we're going to choose the size, and the size really depends on what you want to pay in resources, and it'll give you an idea about the prices. We're going to start with a minimum 1 core 3.5 gigabytes, and if we had it continuously on, it'd be about $96 a month. We're going to turn it off once we do create it, though, so it doesn't burn too much of our money that's already been given us through the Essentials program. There's a bunch of different options that you can pick here for high availability, extensions, your protocols, and then as you go through the wizard, you'll eventually get to SQL Server, the port you want. Do you want it private or public? I want it public so I can access it, along with some other things like when you need patching done. It's going to eventually give you can actually enable or disable R services on well. So if you're installing R, you need to enable this in order the services for R to be installed. When you click OK, you'll get a summary, and then you could start it. It takes a while to create it, maybe about 5 or 10 minutes, but if you think about it, we were able to just now create a virtual machine in the cloud in less than 15 minutes. I'm going to go back to my dashboard and click on Thomas Azure, which is one that already has been started. Here is a set of menu choices where I can start and stop or even move it to a different resource. It even gives me some stats over time of what's been going on with my VM and activity log, and even down here is my SQL Server configuration. So now that I have this created, if I go back to that main dashboard, you're going to see a public IP address. If I copy this address and go into SQL Server Management Studio, I can connect to this IP address, and watch how quick this is to connect to a VM in the cloud. And now through my local on-premise SQL Server Management Studio, I am now connected to that VM in the cloud. There's some resources you can look at, including this site for stretched databases, to tell you about the benefits as well as what it does, and gives you kind of a roadmap for what's going on. There's also a site that'll step you through enabling stretched database on your on-premise server. We're going to go through that, but what we needed to look at first was what's called an advisor, and this is the database migration assistant. You can actually launch it or install it from your SQL Server Installation Center under Planning. If you go down about halfway, there's one called Download Upgrade Advisor. If you don't have the installation ISO, then you could just go online and download it. Once it's downloaded and installed, you're able to create projects. So we're going to do an assessment and we'll call this Learn Now Online, and we're going to pick our source, and then we're going to pick a SQL Server on Azure Virtual Machine. I'll click Create, and what I'm not looking is for compatibility issues because I'm actually using a 2016 database already. But what I want to do is the new feature recommendation. Once I click Next, it'll ask me what server to connect to. It's my on-premise. I'm looking at the AdventureWorks 2016 database, and I'm going to start my assessment. It's going to take a little while, but what we're going to get is it's going to show us, if you remember, the tables that it believes to be able to be migrated. So this is the feature recommendations. What we're going to do is go to the tab that's called Storage, and there's a high, medium, and low value for stretch. The first thing it says is that our sales order tracking table and our sales order detail on disk are available or suggested to be stretched. But if we scroll down, we'll see the issue is the table has check constraints. So there's some check constraints that might or might not be able to be removed. One of them that's really picky is a foreign key. So you have to watch if you're a child of a foreign key. One way can be used, parent, and the other way, parent can't be used, but child can be. There's also some optimized storage. It's telling us that some of the things like the line total can't be used and some of those check constraints. And then we actually get descriptions of the impact and some recommendations on each one of these features. You can even export the report to be reviewed later. In order to use our database stretch, there's going to be some settings you need to do, and you need to prepare because you're going to want to use a filter in order to predicate what goes into an Azure Data Warehouse database. If you notice on our right, we have some scripts. One of them is on your on-premise database. You're going to have to execute the sp_config to change remote data archive property to 1 and then reconfigure. No reboot or restart is necessary there. There is a remote endpoint, and that is the link to the Azure database. This is something you have to set up in Azure once you create the SQL database. You have to enable the IP address or range of IP addresses that can access that remote identity, that remote endpoint. This remote data, of course, is in the cloud and it's available locally like it's never been moved. One benefit of putting this stuff into Azure is that it gets automatically backed up. So when you back up your on-premise database, you're not backing up the data in the cloud. Azure takes care of all your high availability inside of the cloud. There's some other things you have to do locally. Here you see the create master key, and you need to encrypt it by using a password. Remember, anytime you use a password, you need to store it in a secure place so other people can have access to it. If you have to export this master key from one instance to another, you will need that password. The next thing is to create a database scope credential for your local database. You have to use the identity, and secret is actually the password that you use inside of Azure. So when you create your Azure database and Azure server, you have to provide an administrative name, which is identity here, and secret, which is password, in order for other people to have access. There's a workflow you can follow with database stretch. First of all, you're going to have to identify the tables. We looked at the advisor to see some suggestions and limitations of tables in your on-premise database. You're also going to have to alter the database, and you can see that syntax on your right. We're going to alter database, database name, some set remote _data _archive equals on, and then your server is going to equal the server in your Azure cloud. You also have to use the credential that was created with the identity and secret or password. Once you do that, you can do a select on some system database table in order to see which ones are actually remote data archive enable. So as a DBA, you can go investigate this on existing servers. The next is the data moves. These things are done automatically. They're automatically copied for you, and they're automatically removed locally. So once you enable this on a table, make it fully archived to Azure, it takes care of everything in the background. Even though you do a select on the table, it knows what data to get from the cloud and what data to get locally. There's also the ability to stop and restart the Azure move of a stretched database. Here we see two new system store procedures, RDA underscore deauthorize underscore DB and reauthorize underscore DB. So you can stop and restart it at will from your on-premise database. This is in case you have to move something in the cloud or even locally. There are many things system-wide that is available to you in order to manage stretch databases. All the data inside of your table does not have to be in Azure, even though it could be. Here on the right, you see the alter table statement, the one on dbo.customer that sets this table for remote underscore data underscore archive equal on. We also have the migration state equals paused right now, just so it doesn't move any data. Once we start or stop it, it'll use the predicate in order to import or move down that data from the cloud. The predicate function is needed, and it's going to filter your rows to migrate. This is an important step if you don't want all your data in the cloud. What you might want to use is a date, status, or some constant. So for instance, a date time that's sequential. Or you might even just stick with a single column that has two values, 0 or 1 for status. 0, keep on premise. 1, go ahead and put in the cloud. That way you can control row by row. Now, there are some restrictions to the predicate function. It must not be deterministic. Also, you can have no sliding window function. That is, say you want to dynamically move stuff relative to today's date. That is not possible, and you're going to have to handle that locally in your own code. In order to stretch data, you're going to have to do some configuration to your tables. Here you see our dbo.customer table has a column on the end called on-premise. It could be 1 or 0. You have to use an update filter predicate to let the restrictions on what is inbound and outbound from the Azure cloud. The signature of this filter cannot be changed. If you do want to change it, you will have to drop everything and recreate it. It is schema bound, so when you make this a function in this predicate into the Azure database, the structure of the table cannot change. It is schema bound for the inline function, and that does restrictions. You do have to remember that Microsoft is a cloud-first development now. So what we're seeing now in SQL Server 2016 is brand new to the on-premise version. That does not mean they've already made advances in the cloud for updates, so it wouldn't be schema bound. So I would predict in future versions this would be changed. But Stretch Database is a great, fully functional feature of SQL Server 2016. Here's your inline table function. Create function, fn customer Azure. You pass a parameter, which is a bit in this case, at on-premise. It returns this table, and you have to have with schema binding inside of it. So then you start your function with as, and it returns a table. Select one as is underscore eligible, where on-premise equals 0. The reason we have 0 is because 0 means not on-premise. Then you're going to actually have to do something with the table itself because it has to return a table. So you alter table. Here's the alter table DBO customer. You set a property remote underscore data underscore archive equals on. Your filter predicate equals the function that was created earlier, passing the column on-premise. Then you indicate to the table what the migration status is. It's outbound. Remember, we had paused earlier. You can also have inbound if you want to reverse the flow of the data. So this is a very important step, and it indicates the workflow that needs to be executed first. You need a column for the identification of what goes inbound versus outbound, inbound on-premise, outbound in the cloud. You need to create that filter predicate function, remembering the schema binding, and you cannot do table changes once it's enabled, and then the inline function is associated with the table. Remember these restrictions, and also remember when you run the advisor, it's going to tell you which tables it suggests to Azure and which ones do not. Usually it's just archive type data that's not accessed frequently. Of course, we can't leave this topic of stretched databases without talking about some of the limitations. Remember, this is the first release of stretched database to SQL Server in SQL Server 2016. So I predict that some of these limitations will be removed. You can see that sort of thing with things like column store indexes as well as in-memory tables. They were released in about 2012, got better in 2014, and eventually was fully baked in 2016. The first limitation is memory optimized or replicated tables. This is on your source database on-premise. Now, that doesn't mean you can't do it once you put it in the cloud, meaning you could probably create a memory optimized table in the cloud or replicate a table in the cloud. But on-premise, this is a total restriction. If you use file stream on a database, it also adds limitations to what you can do in a stretched database. Your database cannot be part of change data capture if you're using that for, say, ETL in a data warehouse. If you're using a global one like change tracking, that's also something that's not enabled. Look for changes in that in future versions of SQL Server. Of course, the database advisor is going to tell you what data types are supported and not supported. I would not go to any extreme lengths of changing your database types just to support this functionality. There might be a better option for you. Things like timestamp, SQL_variant, XML, geography, and geometry are not supported. If you're using these kind of data types, I would suggest at the database design level to put them in separate tables where you have a one-to-one relationship between it and the other table. Your application or store procedures and functions will have to enforce this integrity of one-to-one, because of course you could have one-to-many in foreign key relationships as well as null rows. But these types of columns are not typical in returning data to a net database application. So look to move those. There's a lot of things like CLR, UDTs, or computed columns that are also not supported. I would look to put computed columns in a view. And if you're using CLR for some .NET programming for the user-defined data types, I would look to see if SQL Server now provides something in place of using CLRs. Now, your indexes are what speeds everything up, and if you have indexes on XML, I would still suggest moving those to a separate one-to-one table. If you're using full text, there's a lot of searching going on. You might look at something else like big data type applications in order to handle full text. Spatial is like geography and geometry, and of course you have your column store indexes, which speed things in data warehouses. This stretched database might be more relevant to a OLTP rather than an OLAP type database where you would use column stores. There's also some constraints that are not supported. A check constraint on a column or a default on a column might not be supported, and your table will not be able to be stretched. I would look for these to change in future releases of SQL Server. If the table is the parent of a foreign key, it cannot be stretched. An example, You have an order header table and an order detail table. The order detailed is the child of the order header. Your order header would not be stretched, cannot be stretched, but your order detail could be. Now, the order detail might have foreign keys to things like product or shipping or other dates, but that is still the child. So look for your detail lines to be able to be stretched, but not your header tables. A unique constraint is not used on Azure databases. So when you stretch it, you can't stretch that constraint to the cloud. It doesn't limit the table from being used, but it does not provide that in the cloud. So you think, well, what happens if something gets duplicated in the cloud? It cannot, because your table locally is enforcing the constraint. And remember, when you put a table in database stretch in Azure, it cannot be updated or deleted. So there's no way anyone can change or put a duplicate in that table. Azure DBs, of course, what we just said, cannot have update or delete done to them. Remember, this is an archive type utility being added in SQL Server. So don't look for things like update or delete ever to be provided. The delete table and config and start over is your workflow if you have to change things in the table structure or in the database itself. You saw the steps, there's not many, so duplicating it might be just saving your scripts and practicing over and over again. You cannot do the alter table on the table once it's stretched to the database. Again, you're going to have to look at being able to delete table, config, and start all over.